uniquely determine the values of other attributes in a table. In BCNF, every determinant must be a candidate key. Candidate keys. Candidate keys are minimal superkeys, meaning they uniquely identify each row in a table. BCNF, every determinant must be a candidate key, ensuring that there are no non-trivial functional dependencies on non-prime attributes. Decomposition of if a table contains functional dependencies where the determinant is not a candidate key, the table should be decomposed into multiple smaller tables to eliminate these dependencies and achieve BCNF. Consider a table named Student Course that stores information about students and the courses they are enrolled in. Student ID, course ID, student name, course name, credits, 101, John Smith, Mathematics, 3, 2, 102, Alice Brown, Physics, 4, 3, 103, Lisa Johnson, Chemistry, 3. In this table, the primary key is student ID, course ID. The attributes student name and course name are functionally dependent on student ID and course ID, respectively. The attribute credits is functionally dependent on both course ID and course name, but course ID is already part of the primary key. Therefore, the table satisfies the requirements of 3NF, but not BCNF. To bring the table into BCNF, we decompose it into two separate tables: student, student ID, student name. 1, John Smith. 2, Alice Brown. 3, Lisa Johnson. Course, course ID, course name, credits. 101, Mathematics. 3, Physics. 4, Chemistry. 3. Now, each determinant in the student course table is a candidate key, and the table satisfies the requirements of Boyce-Codd normal form, BCNF. Thanks for watching the database management system lesson. Hope you enjoyed. To learn more about database management system, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to Advanced Database Management System. In this section, we discuss about primary keys and foreign keys. Let's enjoy. Keys, specifically primary keys and foreign keys, crucial components in relation design. They establish relationships between tables and ensure data integrity. Here's an explanation of primary keys and foreign keys. Primary key. A primary key is a column or a set of columns that uniquely identifies each record. It must have a unique value for each row, and it can null values. Primary keys are defined in the table using the primary key constraint. By default, primary keys also typically have an association for fast data retrieval. Example, in a table of employees, the employee ID column could be designated a primary key. Key. A foreign key is a column or a set of columns in one table that establishes a link to a primary key in another table. It represents a relationship between two tables. Values in the foreign key columns of one table match the values in the columns of another table. Foreign keys in referential integrity, ensuring that values in the referencing tables key columns exist in the referenced table's primary key columns. Foreign key defined using the foreign key constraint. Example, in a table of orders, a foreign key referencing the customer ID column in the customer table establishes a relationship between orders and customers. Table employees, ID, first name var 50, var 50, department ID, foreign key, department ID references departments, department ID. Table department ID int primary key department name var 50 4. In this example, the employees table employee ID designated as the primary key. The departments table also has a primary key department ID. The department ID column in the employees table as a foreign key that references the department ID column in the departments table. Establishing a relationship between the two tables. This ensures every value in the department ID column of the employees table corresponds to a valid department ID in the departments table. Thanks for watching the Advanced Database Management System. Hope you enjoy the lesson. Learn more about database management system. Please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about check constraint data validation, data integrity, multiple check constraints. Let's enjoy. check constraint is a rule or condition applied to one or more columns in a database table to ensure that data values meet specified criteria. Here are the key points. Check constraints. Data validation. Check constraints enforce data validation rule by defining conditions. Data values in the specified columns must satisfy. These conditions can include data type checks, range checks, format checks, or custom validation rules enforced by the database engine. Check constraints are enforced by the database management system, DBMS. Automatically validated data is inserted or modified in the table. Creation syntax. Check constraints are typically defined using a SQL statement such as alter table or create table. For example, alter table, table name, add constraint, check constraint name, check condition definition. Conditions specified in a check constraint can be valid SQL expression that evaluates to true or false. It can reference values, constants, functions, or subqueries. Data integrity. Check constraints play a crucial role in maintaining data integrity by ensuring that data values meet predefined criteria and rules. They prevent invalid or out-of-range data from being inserted or updated in the table. Uses. Check constraints are commonly used to enforce domain-specific rules or constraints on column values. Examples include checking valid date ranges, numeric ranges, string lengths, enumeration values, business-specific conditions. Multiple constraints. A table can have multiple check constraints on different columns or combinations of columns. Each check constraint is a separate validation rule for the specified. Performance considerations. While check constraints provide data integrity benefits, they can also impact database performance, especially during data modification operations. Complex checks or constraining subqueries may require additional processing. Declarative constraint definition. Checks are a form of declarative constraint definition. Constraint rules defined as part of the database schema. Declarative constraints are preferred over procedural constraints. Example, triggers, as they are easier to manage and maintain. Error handling. When a check constraint is violated, i.e., when a data value does not satisfy the specified condition, the DBMS typically raises an error and prevents the operation that would violate the constraint. Example, insertion or update. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about database management, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about primary key constraint uniqueness, non-nullability, uniquely identified rows. Let's enjoy. A primary key constraint is a rule or condition applied to database table column or combination of columns that ensures each row in the table is uniquely identifiable. The key points about primary uniqueness. A primary key constraint enforces the values in the specified columns. No two rows in the table can have the same values for the primary key columns. Non-nullability. Primary key columns cannot contain null values. Every row in the table must have a null value for the primary key column. Uniquely rows. The primary key identifies each row in the table. It provides a means of referencing individual rows at established between tables. Enforced by the engine. Primary key constraints are enforced by the Database Management System (DBMS) and are automatically checked when data is inserted or modified in the table. Creation syntax. In most relational database systems, you define a primary key constraint using a SQL statement such as alter table or create table. For alter table name, add constraint pk constraint name prime key column 1 column 2. Automatic indexing. In many systems, creating a key constraint creates a UX on the primary keys. Prove query performance key lookups. Single column or composite keys. A primary list of a single column or a combination of columns. Composite keys are used when a single column cannot identify rows. Relationships. Primary keys often used to relationships between tables through constraints. Foreign keys in related tables ref primary keys of the parent table. Immutable. Primary keys should be immutable or rarely change. Modifying primary key values can have issues for data and referential integrity tables. Important data integrity. Primary keys play a crucial role in maintaining data integrity by ensuring that each row is uniquely identifiable, facilitating data retrieval and manipulation of. Overall, primary constraints are fundamental to relational database design, essential for maintaining data, enforcing uniqueness, and relationships between tables. Thanks for watching the Advanced Database Management System lesson. Hope you enjoyed the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about foreign constraint, referencing columns, in referential integrity, cascading actions. Let's enjoy. Foreign key constraint is a condition applied to a table column that establishes a relationship in two tables. Here are the key points about foreign key constraint. Relationship tables. A foreign key constraint is a relationship between tables. A parent table, reference a child table, referencing table, referencing columns. The key columns in the child table reference the primary key or unique in the parent table. This creates a link between row table, adding rows in the parent table. Enforced referential integrity. Foreign key constraints inferential integrity by ensuring that values in the foreign columns of the child table must match values in the primary key or unique key columns of the parent table. Creation syntax. Foreign key constraints are typically defined using a SQL statement, alter table, create table. For example, alter table, child table, add FK constraint name, foreign key, child references parent table, parent column. Automatic indexing. In many datums, creating a foreign key constraint automatically creates an index on the foreign column. This can improve query performance for foreign key lookups. Cascading actions. Foreign key constraints can specify actions to perform on related rows in the child table when counting rows in the parent modified or deleted. Common actions include cascade, propagate changes, restrict, prevent changes, set null, set values to null, and set default, set foreign key values to default values. Many relationships. Constraints are commonly used to represent many-to-one relationships between. For example, foreign key in the orders table, the customers table, establish a one relationship, indicating that multiple orders can belong to a single customer. Importance for data integrity. Foreign key constraints are essential for maintaining data integrity and consistency in relational databases. They prevent auth in child tables and ensure that relationships between remain valid. Performance considerations. While foreign key constraint data integrity benefits, they can affect database performance, especially modification operations. It's important to consider the design and indexing key columns to minimize performance overhead. Constraints and relations. Foreign key constraints, conjunction primary key constraints, and constraints in the parent table to establish between tables. Foreign keys reference unique keys in the table to maintain referential integrity. Foreign key constraints play a role in defining and enforcing relationships between relational database. They ensure referentiality, prevent data consistency, support the establishment of meaningful data relationships. Thanks for watching the Advanced Database Management System lesson. Hope you enjoyed the lesson. To learn more about database management system, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about unique constraint, single column or composite constraints, performance considerations. Let's enjoy. A unique constraint is a rule or condition to a database table column or combination of columns that ensures that all in this columns are unique across the table. Here are the key points about unique constraints. Uniqueness. Unique constraint enforce the uniqueness of values in the specified columns of a table. No two rows in the table can have the same use for the unique constraint columns. Non-nullability. Unique constraints allow null values specifying columns. But if a column is marked as unique, only one row have a null value in that column. Enforced by a database engine. Constraints are enforced by the database management system (DBMS) and are all checked when data is inserted or modified in the table. Creation syntax. Unique constraints are typically defined using a SQL statement. Table or create table. For example, alter table name, add unique constraint name, unique 1, column 2. Automatic index. In many database systems, Creating a unique constraint automatically creates a unique index on the unique constraint columns. This helps improve query performance for unique value lookups. Single column or composite constraint. Unique constraint can be defined on a single column or a combination of multiple columns. Composite unique constraints are used when a single column cannot uniquely identify rows. Relationship to primary key. While primary key constraints also enforce unique constraints are used do not serve as the primary key. Unique constraints are often applied to columns that require uniqueness, but are not used for primary purposes. Data. Unique constraints play a critical role in maintaining data integrity, preventing duplicate values in specified columns. They ensure row in the table contains unique data values and help avoid data anomalies. Use cases. Constraints are used on columns such as email addresses, username, identification numbers, or other fields where uniqueness is required, but not necessarily the primary means of identifying rows. Performance considerations. While unique constraints provide data integrity benefits, they can also impact database performance, especially during data modification operations. It's important to carefully consider design and indexing of unique constraint columns to minimize overhead. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about database management system, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database course. In this section, we discuss about relationships, characteristics of relationships, types of relationships, design considerations, understanding and properly defining relationships. Let's enjoy. Relationships in the context of relationship modeling and database atabases represent the associations or connections between entities. They describe how entities are related to each other and in the relations between them. Relationships are crucial for understanding the structure of a database and for ensuring that data is organized effectively. Detailed explanation of relationships. Characteristics of relationships. Association. Relationships represent the associations or connections between entities in a database schema. They define how instances of one entity instances of another entity. Cardinality. Cardinality describes the number of instances of one entity that can be associated with one instance of another entity. Cardinality can be one-to-one, one-to-many, or many-to-many. Directionality. Relationships can be unidirectional, bidirectional, whether the association is one-way or two-way. Attributes. Relationships may have attributes which properties or characteristics specific to the association between entities. Attributes of relationships are stored in associative entities when necessary. Degree refers to the number of participating in a relationship. Relationships can be binary, involving two entities. Ternary, involving three entities or higher degree. Types of relationships. One-to-one, one-one. One-to-one relationship, each instance of one entity associated with exactly one instance of another entity, and vice versa. Example: one employee has exactly one office. Each office is assigned to one employee. One-to-many, one-many. In a one-to-many relationship, each instance of one entity can be associated with 0, 1, or multiple instances of another entity, but each instance of the entity can be associated with at most one instance of the first entity. Example: department, multiple employees, but each employee belongs to only one department. Many-to-one, M-to-one. A many-to-one relationship is the inverse of a one-to-many relationship. Multiple instances of one entity created with exactly one instance of another entity. Example: multiple employees report to the same manager, but each employee reports to manager. Many-to-many, M-to-M. In a many-to-many relationship, multiple instances of one entity can associate with multiple instances of another entity. Many-to-many relationships are typically resolved into one-to-many relationships using associative entities. Example: many students enroll in multiple courses, and each course can have multiple students. Represent Representation. Relationships are typically represented graphically using a diamond shape. The related entities in an ER diagram. Cardinality indicators, such as 1, M, are often used on the relationship to denote the number of instances involved in the relationship. Design considerations. Accurate representation. Accurately represent the associations between entities based on the requirements of the domain being modeled. Normalization. Relationships should be normalized to fluency and ensure data integrity from the principles of database normalization. Clear definition. Relationships should be clearly defined with a cardinality and participation constraints to avoid ambiguity and ensure consistency. Database schema. Understanding and properly defining relationship between entities is crucial for designing an efficient data schema. Relationships help in organizing data effectively and capturing the complex interaction between different entities in a database system. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about database management system, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to Advanced Database Management System. In this section, we discuss about importance of databases, data analysis and insights, scalability and performance, business continuity and disaster recovery, regulatory compliance. Let's enjoy. Databases are of paramount importance in today's digital age due to several key reasons. And storage. Databases provide a structured framework, organizing and storing amounts of data efficiently. By structuring data into tables and columns, databases enable easier manipulation and analysis of information. Data integrity and consistency. Databases enforce data integrity rules, such as constraints and validations, to ensure the accuracy and consistency of stored data. This helps maintain data quality and reliability, crucial for making informed decisions and conducting business operations. Data accessibility. Databases allow multiple users or applications to access and manipulate data concurrently while ensuring data consistency and integrity. This enables collaboration among teams, supports real-time decision-making, and facilitates seamless integration with various applications and services. Data security. Databases measures include authentic authorization and encryption. to sensitive data from unauthorized access, manipulation, and disclosure. Ensuring data security is essential for safeguarding financial information, complying with regulations, and maintaining trust with customers and stakeholders. Analysis and insight. Databases serve as repositories for historical and transactional data, enabling organizations to perform in-depth analysis, generate reports, and valuable insights. By leveraging data analytics tools and techniques, businesses can uncover patterns, trends, and correlations that drive strategic decision-making and competitive advantage. Scalability and performance. Databases are designed to scale horizontally or vertically to accommodate growth of data accessing user demands. Whether it's adding more servers, optimizing query performance, or implementing caching methods, databases provide scalability and performance to ensure seamless operation and responsiveness. Business continuity disaster recovery. Databases offer data backup, replication, and recovery. Minimize the risk of data loss due to hardware failures, natural disasters, or human error. Implementing robust backup and disaster recovery strategies ensures business continuity, reduces downtime, and protects against potential disruptions. Regulatory compliance. Databases play a crucial role in ensuring regulatory compliance with industry standards and government regulations, such as GDPR, HIPAA, PCI DSS, and SOX. By maintaining accurate records, auditing data access, and implementing appropriate security controls, databases help organizations meet compliance requirements and mitigate legal and financial risks. Thanks for the database management system lesson. Hope you enjoy the lesson. To earn more database management system, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to the Advanced Database Management System course. In this section, we discuss choosing the right DBS for your project or application is a critical decision that can have a significant impact on its performance. Let's enjoy. Choosing the right database management system, DBMS, for project or application is a critical decision that can have a significant impact on its performance, scalability, and here are some factors to consider when selecting a DBMS. Data model. Consider the data model best fits your application requirement. If your data is highly structured and requires complex relationships, a relation may be suitable. For unstructured or semi-structured data, a NoSQL database to fit. 2. Scalability. Scalability requires of your application. If you anticipate a large volume of data or high traffic loads, choose a DBMS that supports horizontal scalability, such as a NoSQL database or a cloud-based solution. 3. Performance. Evaluate the performance characteristics of different S options, including read and write throughput, latency, and concurrency. Consider factors such as indexing, caching, and query optimization techniques that can affect performance. 4. Consistency. Determine the consistency requirements of your application. Some DBMSs offer strong consistency guarantees, ensuring that all see the same data at the same time. Others may offer eventual consistency, where updates are propagated asynchronously and may take time to propagate to all developers. 5. High availability. Consider the availability requirements of your application. Choose a DBMS that provides built-in fault tolerance, replication, and automatic ability to ensure continuous availability and durability. 6. Security. Evaluate the security features different DBMS options, including data encryption, authentication, access control, and auditing. Choose that provides robust security mechanism to protect sensitive data from unauthorized access and breaches. 7. Ease of use. Consider the ease of use and administration of DBMS, including installation and maintenance tasks. Choose a DBMS that provides intuitive management tools, documentation, and community support to simplify these tasks. 8. Cost. Evaluate the cost of acquiring, licensing, and operating the DBMS, including ongoing maintenance fees and service charges. Consider both the initial investment and long-term total cost of ownership (TCO) when making your decision. 9. Ecosystem and integration. And integration abilities of the DBMS, including compatibility with programming languages, frameworks, and third-party tools. Choose a DBMS that integrates seamlessly with your existing technology stack and provides robust APIs and connectors for data integration. Thanks for watching the Advanced Database Management System lesson. Hope you to learn more about database management system, please check the next lesson. Stop learning. Thanks once again to enjoy the lesson. Welcome to my advanced database management system course. In this section, we discuss about database design tools and techniques, unit modeling language, UML data modeling tools, indexing strategies, prototyping, and iterative design. Let's database design, creating a blueprint that defines the structure and organization of data in a database system. Several tools and techniques are available to assist database designers in this process. Here are some commonly used tools and techniques for database design. 1. Entity relationship diagrams, ERDs. ERDs are graphical representations used to model the entities, objects or concepts, attributes, properties or characteristics, and relationships between entities in a database. They help visualize the structure of the database and define the relationships between different entities. Unified Modeling Language, UML. UML is a standard modeling language used in software engineering to visualize, specify, construct, and document software systems. Class diagrams, UML, can be used to model the structure of a database, including entities, attributes, and relationships. Database management systems, DBMS. DBMS tools such as MySQL Workbench, Microsoft SQL Server Management Studio, and Oracle SQL Developer provide graphical interfaces for designing and managing data. These tools allow designers to create database schemas, define tables, and establish relationships using visual designers. Data modeling tools. Dedicated data modeling tools like ER Studio, Lucidchart, and Vertebolo offer features for creating and visualizing database designs. These tools often include support for generating DL, data definite scripts, reverse engineering existing databases, and collaborating with team members. Normalization techniques. Normalization is a process used to organize data in a database to minimize redundancy, and dependency. Various normalization techniques, such as first normal form, 1NF, second normal form, 2NF, third normal form, 3NF, form, ENF, fourth normal form, 4NF, and fifth normal form, 5NF, help ensure data integrity and optimize database performance. Indexing strategies. Index technique to improve the performance of database queries by creating data structures. Indexes allow for faster data retrieval. Designers must consider the appropriate indexing strategies based on query patterns, data distribution, and performance requirements. Data modeling notations. Different notations used in data modeling to represent entities, attributes, relationships, and other elements of a database schema. Common notation, crow's foot notation, chain notation, and buckets notation, each with its own conventions for visualizing database designs. Data dictionary. A data dictionary is a centralized repository that contains metadata about data, describing the structure, definitions, and relationships of data elements in a data, but serves as a reference guide for database designers, developers, and users to understand the data model components. Prototyping and iterative design. Prototyping involves creating early versions of the database schema to gather feedback, validate requirements, and refine the design iteratively. Agile methodologies like Scrum and Kanban continue improvement and collaboration throughout the database design process. Documentation. Documenting database designs is essential for ensuring clarity, consistency, and maintainability. Designers should document design decisions, data definitions, constraints, and assumptions to facilitate communication and knowledge transfer amongst us. Thanks for watching the Advanced Database Management Series. Hope you enjoy the lesson. To learn more about database management, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about inserting data into tables. Let's enjoy. To insert data into tables in a relational database, insert into statement. Here's the basic syntax for inserting data into a table. Insert into table name, column 1, column 2, column 3. Value 2, value 3, slash. Table name of the table where you want to insert data. Column 1, column 2, column 3, optional column names where you want to insert data. If you specify, you must provide values for those columns in the same order. Values value 1, value 2, value 3, slash. The values be inserted into the specified columns. The number of values must match the number of columns specified. Example of inserting data into a hypothetical students table with columns student ID, name, and age. Insert into student ID, name, and values 1, John Doe, 20, 2, 22, 3, Alice, 21. This SQL statement inserts 3 rows into the students table with values for the student ID, name, age column. Alternatively, you can insert data into all columns of a table without specifying column names. Like this. Insert into values 1, John Doe, 20. Insert a single row into the students table, assuming the order of the value matches the order of columns in the table. Remember to replace students with the actual name of your table and provide appropriate values for each column according to the data types defined in your data schema. Thanks for watching the Advanced Management System lesson. You enjoyed the lesson. To learn more about database management system, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Data Management System course. In action, us about updating and deleting data. Let's enjoy. Deleting data in a SQL database are performed using update and deletes respectively. Updating data. The update statement is used to modify existing records in a table based on specified conditions. Here basic hacks. Update table name, column 1 equals value 1, 2 equals update table name, set column 1 equals where action. Table name, the name of the table where you want to update data. Set columns you want to update along with their new values. Where can optional condition to specify which records should be updated. If updated, all records table will be updated. Example. Update employee salary equals 50,000 where department equals sales. This SQL statement updates the salary column for all employee sales department to 50,000. Deleting data. Statement is used to move one or more records from a table based on specified conditions. Here's the basic syntax. Delete from table where condition. Table name, the name of the table from which you want to delete data. Where condition, optional condition to specify which records should be deleted. If omitted, all records in the table will be deleted. This SQL statement deletes all students from the students table who are older than 25 years. Delete where age equals 25. Note, be cautious when using delete statements, as they permanently move data from the database. Always ensure that the clause is used correctly to target the intended records for deletion. Similarly, when using update statements, ensure that you specify the conditions accurately to avoid unintended modifications to data. Thanks for watching the Advanced Database Management lesson. Hope you enjoy the lesson. Learn more about database management system. Please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about sorting data. Let's enjoy. Sorting data in SQL is in the order by clause in conjunction with select statement. The order by clause allows you to specify the order in which the result set should be sorted based on one or more columns. Here's the basic syntax. Select column 1, column 2 from table name. Order by column 1, desk 2, column 1, column 2, ASC, the columns you want to sort the result set by.